Hello everyone, I welcome you all to this tutorial wherein I'll take you through sources of distortion in wireless communication. So there can be many sources of distortion in wireless communication. Starting with here we can have reflection and refraction as well as diffraction, and here we have scattering, and along with these three we have one more thing called as attenuation. Attenuation: as signal wave propagates through air, the signal strength is attenuated. The attenuation is proportional to the distance traveled over the air. This results in path loss for radio waves in the air. Then we have this reflection and refraction. As you can see here, there are two nodes that which can transmit signals in this fashion. So this is the reflected ray that is reaching the other node, and few other components are getting lost because of refraction. Reflection and refraction: when a signal wave is incident at the boundary between two different types of material, a certain fraction of wave bounces off the surface, which is called reflection. Depending on the properties of the two materials, a certain fraction of wave may also propagate through the boundary, which is called as refraction. Reflection and refraction are usually observed on ground or walls of the building. As a result, the received signal may fade based on the constructive or destructive effects on multiple waves that are received at the receiver. And then we have this diffraction. So diffraction usually happens at the sharp edges, like top of the mountain, or it can also be a building. So this causes the sharp edges to act like a new source. So this tip is acting like a new source from which the signals, we are getting 4 more new signals where waves are generated. In effect, the signal strength is distributed to new generated waves. And finally, we have scattering. Signals or waves do not generally encounter perfect boundaries. Instead, when a signal wave is incidented at a rough surface, it scatters in all directions. So that scattering is denoted over here. So when the signal lands on a very rough boundary, it scatters in all the other directions. So this is about distortions and sources of distortion in wireless communication: attenuation, reflection, refraction, diffraction, and scattering. And then we have one more important topic called as joint source channel encoding. So this joint source channel encoding is something where both source as well as channel are grouped together. We are trying to make a joint out of it, and then we code it. So but whereas traditional information theory and coding, just they have seen that it separates source encoding and channel encoding separately, as information and channel exhibit independent characteristic in such cases, as information generated by application are related to the user. So user dependent data will be there, and it differs from person to person. So thereby these has to be separated. Both source and channel has to be separated because they'll exhibit independent characteristic. But whereas in wireless sensor network, the characteristics of source is closely related to that of the channel. Traditional ITC separates separation technology because it's all in the digital domain. But whereas joint source and channel technology, here analog communication has to be used, so thereby it's quite complex to implement, and it basically makes use of spatio-temporal model, so where it depends upon time as well as spatial location of the sensor node. And in turn, here we have a single source. The source can be divided into several events like S1 of n, S2 of n, Sm of n, and Sn of n. So where these numbers, subscript numbers, indicate the number of nodes, where we'll be considering only a subset of these total number of nodes, that is m till m, where we'll think that these subset starting from 1 to m are the set of subset of the sensor nodes that which are actually identifying a physical phenomena. And these physical phenomena, when sensed by the sensor in a noisy environment or an ambience, so noise gets added up to this, and this results in observed phenomena x1 of n, x2 of n till xm of n, and in turn this will be encoded. So after encoding, it converts to y1 of n till ym of n, and in turn this all these y's will be in turn sent by the help of wireless sensor network to the destination, wherein by the time when it reaches the destination, it will call it as zi of n, and using this zi of n we can estimate how exactly this source source actually looks like, or the physical phenomena. So this is about source joint source channel encoding.